So in this lesson, when we're starting in chapter 7 with factoring, in this lesson we're working with the greatest common factor. That should sound familiar to you. Greatest common factor, the largest factor that divides out of a term, expression, and whatever it is that you're trying to factor. You're gonna, when you're told to find the greatest common factor, I'm going to call it GCF. I'm going to be like, see if you can GCF it. And then when I'm saying that, I'm asking you to find, is there something that you can divide out of both and find the largest thing that you can divide out of both. And if the only thing you can divide out of both is 1, then your GCF would actually just be 1 and it wouldn't change anything. So if I ask you to GCF something, that's what I'm asking you to find, is the greatest common factor. So here's an example. The GCF of 4 and 12 is 4. Because 4 can be divided out of both of them. 4 divided by 4 is 1. And 12 divided by 4 is 3. And there's no other integer. We look for integer values that we can divide out. No other integer other than 1 can be divided out now. They could both be divided by some other things, like 1/2, 1/3, whatever. But we want integer values to be our factor. So if we can't divide anything out other than 1, we know we've got the GCF. Okay, so we're just going to practice on the front side here, working with GCFing some integers. No variable expressions involved, just constants. So what is the GCF, do you think, of 15 and 40?
5.
5, okay. So sometimes what you have to do is you just have to start with a number that you know goes into both of them. And so you say 15 divided by 5 is what? 3. And so that divides in nicely. 40 divided by 5 is 8. So they were both divided by 5, right? So right now we could stop and say we think the GCF is 5. But before we stop and do that, we have to make sure there's nothing else that can be divided out of 3 and 8 other than 1. Is there? Is there any other integer you can think of that divides into 3, that also divides into 8, other than 1?
No.
Okay? So we stop right there and say the GCF is 5. Okay. How about number 2, 39 and 13?
13.
I think 13. So does 13 go into 39?
Yes.
Okay. So we could start with that. We could say, okay, well, what is 39 divided by 13? Because we know 13 is going to be divisible by 13, right? 3. So 13 or 39 divided by 13 is 3. And 13 divided by 13 is 1. So right now, so far, we have divided both of them by 13. Is there anything that goes into 3 that also goes into 1 other than 1 itself? No. So we say the GCF of this one is 13.
Okay, I know it's like opposite, but how does this have to do with polynomials?
Okay, you're going to find out when we go to the back side.
Yeah. The front's easy, the back is what's going to mess me up.
Okay, so we have to be able to, and the reason that GCFing is important, being able to do that, is so that we can, when we do have to start factoring polynomials, we're going to be able to, if we can divide something out first out of all the terms of a polynomial, called a GCF, if we can divide a GCF out, it's going to make the resulting polynomial easier to work with. So you're going to like that you know how to GCF, trust me. Okay. How about 30 and 75? What do you think is the GCF? 75? Sometimes we can't go right to the GCF, so sometimes we have to just, like say, oh, I know they're both divisible by 5 because they end in 0 and 5. So that's a divisibility rule. Anything that is divisible by 5 ends in 0 or 5. So we say, okay, well, let's divide both of them by 5 and see what the results are. 15 is what 75 divided by 5 is. Okay, so we divided by 5. Is that our GCF?
No.
Why not?
3 can go into 6 and 15.
Yeah, 6 and 15 are still both divisible by something larger than 1. So now we have to go on and say, okay, well, 6 can be divided by 3, I heard, and that is 2. And 15 can be divided by 3, and that is 5. So we just divided now by 3 also.
Y'all sure
So now your GCF is.
So now, can we stop?
Yeah.
How about 2 and 5? Are they
Yes.
divisible by anything larger than 1? No. Okay, so this time we can't say that the GCF is either 5 or it's 3. We have to say that the GCF, and we don't add them, but
We
instead
multiply.
we multiply. 5 times 3. The GCF has to be 5 times 3 because it was divided by both. And remember, dividing is the undoing of multiplying.
I wanted to put 15 in there.
So, Garcia?
Yeah, what about from the start if you just put 15?
You can. But
And then it.
yeah, then you only have to do the one division. You're correct.
Okay.
Yep. Then you only have to do the one division because you knew that 15 went into both of them. So if you can get to the GCF right away, that's cool. If you can't, it's okay to do some extra divisions. But then you have to remember that everything you divided by has to become a factor. In other words, those things that they were divided by have to be multiplied by each other. So we end up with our final answer, because we did 2 divisions, it ending up being 15. Okay. How about 14 and 35?
7.
They're both divisible by 7. Okay, so 14 divided by 7 is 2, and 35 divided by 7 is 5. So we divided by 7. Our results are 2 and 5. How do you feel about that? Can we divide by anything else? No, not anything useful anyway, just 1. Wouldn't get us anywhere. We keep getting 2 and 5, right? So our GCF is what? 7.
For once I feel smart. For once, I actually don't know how to handle it.
Okay, how about number 5? 12 and 49.
Down.
Sometimes the first thing you want to try is just take the smaller one into the larger one. Is 12 going to 49 nicely? No? Okay. Then I look at it and say, okay, well, what are some things that go into 12? Maybe they go into 49. 6.
49
Does
doesn't
go
go to
49?
6, no.
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 Neither does 2.
And neither does 2.
Neither does 3.
3 is another number that goes into 12. Is 3 going to 49?
No.
No. What's
It'd be
another
a
number? What's another number that goes into 12 that we haven't? We've said 2, 3, and 6.
1.
4.
4 does.
4 going to 49 nicely? Okay. Well, then what are we going to say?
No solution.
No, we say the GCF is
0. 1.
1. It's 1. That'd be the only thing we could divide out of
I
it.
said that.
GCF would have to be 1. Or in other words, if I said to you, can we GCF that, you'd say, well, no, not really, Mrs. LeGrand, because the only thing that's, they're both divisible is by 1. So, let's just move on. We can't GCF it. Okay?
Oh my god, this is hard.
So any leftover concerns? We're just practicing GCFing integers on this side. Okay, then let's go to the back where we have algebraic expressions that we need to GCF.
Oh, this is easy too.
So finding the GCF of monomials, that's all we're going to practice right here. Example, we have the monomial 3x and the monomial 9x squared, and I say that the GCF for those is 3x. In other words, the largest constant that I can divide out of the 3 and the 9 is 3, and the largest number of x's I can divide out of x and x squared is just x. One of them has an x and the other one has a couple of x's, so we say, because in reality 3x is the same as 3 times x, right?
Yeah.
And 9x squared is 9 times x times x. So I can, and then I also can rename 9 as 3 times 3, correct? So look at what's going on here. They both have a factor of 3 in common, and they both have one factor of x in common. So the GCF is 3x. Or, like I did here, I said 3x divided by 3x, just like we were doing on the front. We think they're both divisible by 3x, so we do it. 3x divided by 3x is 1. Anything divided by itself is 1. And 9x squared divided by 3x, remember how to divide? 9 divided by 3 is 3. X squared divided by x. 2 upstairs, 1 downstairs. 2 take away 1 is x to the first power. Okay, so first thing we're going to decide here is when we do these, we're going to decide what's the GCF of the constant, the number part, the fact that the multiplication in there that's got the just the number part, and then we're going to GCF the variable part, and then we're going to put our answer together. So we're going to GCF the 8 and the 4 to start with. So what's the GCF of 8 and 4?
4.
Because 8 divided by 4 is 2, and 4 divided by 4 is 1. So feeling pretty confident that we can't do any more than that. The GCF of the 8 and the 4 is 4, just like we just did on the front. Well, now let's deal with the y cubed and the y. So what do you think we can do? What's the most number of y's you think we can divide out of each of those?
1.
Y to the first power, right? So y cubed we think can be divided by y. And y can be divided by y. Now, you know that you have the most number of them if one of these turns out to be 1. Is one of these going to turn out to be 1?
Yes.
Yeah. Y divided by y is 1. As long as you get a 1, now you can say, okay, I've divided out the most number of them I can. And now we ask ourselves, what is y cubed divided by y?
Y squared.
Y squared. It's kind of like, remember, we can write this like this. Y times y times y. This one is just y.
Should that 1 be a y instead of a 1? Why is it a 1?
Because anything divided by itself is just 1.
Just kidding.
So what happens here, when we divide this one, that top one by y, we're just taking one of the y's out of there. And notice what we have left. We have y squared left, don't we? And when we're dividing this one by y, we're taking that y out of there. What's left? Nothing. But remember, when we cancel, whenever we're doing canceling in fractions, when we cancel things out and there's nothing left, we say there's really a 1 there. So that's how we got our 1. So now we say y squared times 1 equals what? Y squared. Oh, I don't think that's what I want there. I don't think that's what I meant for that. No, I did not. Okay. Erase that. That's not what we want there. We have decided that the GCF of y cubed and y is y squared. So just like we did on the front, those of us who took the longer route with that 30, remember, and that 75, first we divided out a 5, and then we divided out a 3. That's what's happened here. We divided out a 4, and then we divided out a y squared. So 4 times y squared is 4y squared. So our GCF is 4y squared. Okay. Why don't you try that next one on your own? 15m to the third power and 25n squared. Remember, just do the number parts first. GCF the 15 and the 25. Do you agree with me that the GCF of 15 and 25 is 5? Okay. What's the GCF of m cubed and n squared? Can m cubed can be divided by m cubed? Can n squared be divided divided by m?
now.
No. So.
It's
maybe
m,
worse.
Are we gonna have to
cubed n
subtract?
squared.
Yeah, it's gonna be n cubed n squared.
Yeah, 'cause you can't, they're different variables.
But they both have to be divisible by whatever you say. So I've heard that they could be m cubed n squared. Well, m cubed. So m cubed, is that divisible by m cubed n squared?
No, it's one.
No. Because that would not get rid of, remember, we gotta get it so that,
It's one.
so the GCF of that one, this is like the front one, remember when we said it's 12 and 49? What was the GCF of 12 and 49? 1. So M's and N's aren't compatible. So we can't have a GCF of M's and N's. It's just going to be 1. So we say 5 times 1 is 5. The GCF this time is just a number. It's just 5.
Well, that's neat.
Sometimes we can't divide any variables out. It's okay. Sometimes you can't divide any numbers out. It's okay. You divide out what you can.
Can we do the next one by ourselves?
Okay, go ahead and try it. What are you doing with that negative 4 and that 10? What are you dividing out?
2.
2. Okay. So, what is negative 4 divided by 2? Negative 2. What is 10 divided by 2? 5. Okay. Is there anything else we can divide out of both of them? Is 5 divisible by negative 2?
Oh, no, I meant.
Oh, no.
It's
So it's looking like if we do 2, then our GCF is going to be 2. That's the best we can do. But is there also a possibility of dividing by negative 2? Yeah. So sometimes we can also divide by a negative number. Sometimes we don't need to introduce a negative, but this time one of them was negative, so we say, well, wait a minute, why can't it be negative 2 instead of positive 2?
You can.
It can. So then this is going to be what? What's negative 2? Negative 4 divided by negative 2? Positive 2. And what's 10 divided by negative 2? Negative 5. So this time we divided by a negative 2. So you get to do either or. And sometimes you're going to find that it's to the advantage to divide out a negative. And other times you're going to be like, I'd rather just divide out a positive. It doesn't matter. It's called, you get to pick which one you want to divide out, okay? But in the end, then, that means we might have a little bit different looking.
You have the marker.
Yeah, that's right. That would be why it's not doing it. Thank you, Matt.
Is the RGCF x squared?
And so now we're going to go on to the x's, and then we'll go back and deal with those, okay? So we have the x to the 5th here and the x cubed, and what do you think is the GCF of those two?
X.
Just x? Okay, well let's see. If we divide by x, what do we have? X to the what? X to the 5th divided by x is
X to the 5th.
x to the 5th, that's 5 factors of x, and we're dividing one of them out of there, so it's x to the 4th. And x to the 3rd divided by x is x to the 2nd.
Oh,
3. Oh, but wait a minute.
Yes.
But are these guys still divisible by some more?
Yeah.
Divided by 2. By 2.
So really, you can take the first one divide by x squared.
Oh.
Okay, so you're saying we could have made it x squared instead? Okay, let's do that. Let's make it x squared instead. Okay, if it was x squared, then what's x to the 5th divided by x squared? X to the 3rd. X to the third, okay. And what's x to the third divided by x squared? X to the first. Feel like we got the GCF now? In other words, x cubed and x to the first are not divisible by anything else?
Yeah, they are. Wait, no, they're not.
They're still divisible by what?
One.
Another x. They still have, this one still has an x, and this one has 3 x's.
So it should have been x to the
So
third.
I'm thinking we could have divided out maybe x to the third. Let's try that. What's going to happen when we divide by x to the third? What's x to the fifth divided by x to the third? X to the
Squared.
second, yeah.
An X
And what's x cubed divided by x cubed?
2.
No.
It's X.
Anything divided by itself is
One.
1. Anything divided by itself is 1. And remember
2x
what I said?
squared.
When we're doing the variables, if we can divide them by something we can't be done until we have 1. Do we finally have a 1?
Yes.
Yes. So
English.
the GCF of this is x cubed.
Yes, I was right.
Okay, now we're going to say, well, if I divided out a 2, and then the other one I divided out an x cubed, I'm going to say my GCF is 2x cubed. That's going to be my GCF. But if I was, wanting to deal with the fact that I just didn't want that negative for some reason, I wanted to divide by a negative for some reason, I divided by -2, and my other GCF was x cubed, then my GCF is going to be -2x cubed. And that's okay. Notice it says or. There aren't 2 GCFs here, there's one or the other. You get to pick which one you like. So you can, if one of the numbers is negative, you get to divide out a negative. If both of them are negative, you can divide out a negative. If they're both positive, don't introduce any negatives, okay? Okay, so again, when we just have integers, we just have to worry about an integer GCF as our answer. When we have variables involved, then there might be some variables in your GCF also. But notice there was one time there wasn't, was there? And we had, in this one, when we had m's and n's, we didn't have a variable in our GCF.
Is our worksheet gonna all have variables?